Pleasant day, everyone. Today, we will solve problem 2813 of the book Fundamentals of Analytical Chemistry. So what will be the contents of this presentation? First is our objectives. Second is our procedure. Third, problem 2813. Fourth, the calculations of problem 2813. Lastly, the result and conclusion. So for our objectives, first objective is to understand the problem and identify the given and unknown values. Second objective, to find the equations that would be used for the calculations. Third objective, to calculate for the unknown lead concentration in the sample using the given values. Last objective, to present the result and arrive at a conclusion. So our procedure, first, step 1. Identify the given values that would be used for calculating the unknown in the problem. Step 2. Construct methods and equations for the computations. Step 3. Calculate the unknown lead concentration using methods, equations, and given values. Last step. Present the result and arrive at a conclusion. So what is our problem? A 5 ml of blood was treated with trichloroacetic acid to precipitate proteins. After centrifugation, the resulting solution was brought to pH 3 and extracted with two 5 ml portions of methyl isobutyl ketone containing the lead complexing agent ABCD. The extract was aspirated directly into air or acetylene flame and yielded an absorbance of 0.502 at 283.3 nanometers. 5 milliliter alicos of standard solutions containing 0.4 and 0.6 ppm of lead were treated in the same way and yielded absorbances of 0.396 and 0.599. The concentration of lead in the sample in ppm. Find the concentration of lead in the sample in ppm assuming the Beer's law is followed. So let's identify the given. First concentration 0.4 ppm lead with absorbance of 0.396. Second concentration 0.6 ppm lead with absorbance of 0.599. And our unknown concentration of sample with absorbance of the sample 0.502. So since the Beer's law is followed, we can derive the equations in a linear way, and our equation 1 would be 0.599 is equal to 0.6 m plus c. 0.3, our second equation is 0.396 is equal to 0.4 m plus c, and our last equation is 0.502 is equal to mx plus c, with x as the unknown concentration of the sample. So we have two methods here for solving the problem 2813. First method is through a linear system of linear equations of equations 1 and 2 and equations 2 and 3. First, we will find the m using equations 1 and 2. Subtracting the equation 1 to equation 2, we get 0.203 is equal to 0.2 m, and dividing both sides by 0.2 to cancel out 0.2 with m, we get m is equal to 1.015. Now subtracting the third equation to the second equation with the value of m, substituting it into the equations, we get 0.106 is equal to 1.015x minus 0.406. Now transpose 0.406, we get 0.512 is equal to 1.015x. Dividing both sides by 1.015, we get our unknown concentration of 0 point, that must have 0.504 ppm net. Method. Our second method, find our second method is through the linear interpolation. We'll use linear interpolation since equation 3 with the absorbance value is between the absorbance values of the given. The first given absorbance value is 0.396 and the second is 0.599 and 0.502 is between the two. So we can say that this is linear interpolation. If it is beyond the range, it is linear extrapolation. Since it is between the range, it is linear interpolation. So finding m using equations 1 and 2, we find we transpose or find the equation in terms of c. Then the value of c or the equation is equated to each other. So we get this equation. Then combining like terms, transposing terms with the m and terms without m, we get 0.599 minus 0.396 is equal to 0.6 m minus 0.4 m. Now we extract m, then we divide 0.6 minus 0.4 to both sides, so we can get m with the value of 0.599 minus 0.396 over 0.6 minus 0.4. So now we find the unknown concentration using m and equations 2 and 3. We subtract the equation 3 to equation 2. We get 0.502 minus 0.396 is equal to mx minus 0.4 m. Extract m, then we get the value of x by dividing both sides with m and transposing 0.4 and substituting the value of m that we computed in the first part of method 2. So for the continuation of method 2, we substituted the value of m. Then since it is dividing by fraction, we can multiply it by the reciprocal of m. So we get 0.502 minus 0.396 times the reciprocal of m, 0.6 minus 0.4 over 0.599 minus 0.396 is equal to x minus 0.4. And we transpose 0.4 so that we isolate x and get the value of x. We get x is equal to 0.4 plus 0.502 minus 0.396 times the value of the reciprocal of m, 0.6 minus 4 over 0.599 minus 0.396. We get the value of X, or the concentration of the sample, X is equal to 0.504 ppm lead. So that's our two methods for calculating problem 228 for. Lastly, our result and conclusion. The following results and conclusions were drawn from the calculations of problem 2813. That would be erratum 2813. The given values that are treated the same way with a sample with a known lead concentration can be transformed into linear equations. So we got three linear equations to solve that we used to solve the concentration of lead in the sample. Second, through system or linear equations and linear interpolation, the unknown lead concentration of the sample can be calculated. And lastly, the value of the unknown lead concentration in the sample is 0.504 ppm lead, which is between the values of the given concentrations. That's all. Thank you.